Do you want to learn how to spawn objects with probabilistic variation? If so, then stick around. Oftentimes in a game, we need to spawn objects such as an enemy going across the screen. Then after that, we might need to spawn enemies periodically that go across the screen like this. However, this looks very predictable as the enemies come across the screen about every 2.5 seconds. We can add some variation in the arrival rate of these enemies while still respecting the average arrival rate of 2.5 seconds. And this would make the game more challenging and playable for a player. We'll start this project with a simple 2D game. What we're going to do is make a small ramp and some ground. Add a 2D square, stretch it out to make it ground, and color it green. Rename it to ground, push it down to the bottom, add a box collider 2D, add another 2D square, stretch this one out, and rotate it about -10 to make a ramp. Push it over to the edge of the screen. Next, we'll add a 2D circle. We will add a circle collider to it, 2D. We'll add a rigid body, 2D, and we'll run it to make sure things are reacting correctly. Good. So I'll move this over, and what we're going to do eventually is spawn several of these, and they will roll down the ramp, and we'll see what happens. And don't forget to add a collider to the ramp. And here we have the ball rolling down the ramp. I'll rename this to ramp, and I'm going to make the angle a little less so that the circle moves a little bit slower. And just for fun, I'm going to add a sprite to it so we can see it rolling. Now, as it stands now, my sprite is too large for this circle, so I will go and edit the pixels per unit on this texture. And it looks like about 400 pixels per unit is a good choice. So I'll rename this circle and I will call it baseball. And now we want to make the baseball our prefab, so drag it down to the assets. And you can delete the baseball up in the scene, as we will be adding them programmatically now. Next, we want to make our object that is going to spawn baseballs. Make an empty object. We'll call it baseball spawner. Add a script to it. We'll call it baseball spawner script. And go ahead and open the script. We'll make a public variable of type gameObject, and we will call it baseball prefab. We'll serialize this so we can get a hook to it in the inspector. Go to the baseball spawner in the inspector and hit the baseball prefab and select our prefab. Go to the assets and choose baseball, which is the name of the prefab. We're going to make a helper function that's going to spawn baseballs at a fixed rate of 1 every 5 seconds. So we stub out a function that returns an I enumerator, and the function is called spawn baseballs at rate, and then we're going to pass in the wait time, and that'll be the time between the spawning of baseballs. And this is pretty simple. All we're going to do is wait for the time passed in seconds. Once that expires, then the function is going to continue on. So we have to decide where we're going to put this baseball. So we'll make a vector 3, then we'll hop back over here and see where we were spawning this baseball before. It was about -13.5 on the X and 3.5 on the Y, so that should be close enough for us. And then we're going to make a call to instantiate. We're going to pick the object we want to instantiate, and we want to create an instance of a ball prefab. We choose the position where we want it to appear, and we pass in quaternion.identity, meaning that we don't want to rotate Now that's the helper function, but we need to start this function up. We'll do that in the start, and what we do, we call start coroutine, and then we give the name of the function that we're going to start up, and we need to pass in an interval in here, and we'll pass in 5 seconds. And we'll hop over to Unity and see what happens. We're going to have a 5-second delay. After 5 seconds, the ball appears and rolls down the ramp. And it's only doing this one single time. To make it spawn baseballs every 5 seconds, we want to just do this code in here forever. So we can simply put in a loop, and we can invoke that code forever. Hop back over to Unity, run the program, and now we'll delay 5 seconds. After 5 seconds, a baseball will appear. And then we'll wait another 5 seconds, and then another baseball appears. And then you can see every 5 seconds, a baseball appears. The next thing we're going to do, we're going to add a user interface element. We're going to display the time between when each baseball appears. So to do that, we'll go up to the hierarchy. We'll add a new UI component, and we'll first add a canvas, and then after we add the canvas, we'll add as a child a UI element, which will be a text mesh pro, and go ahead and import the essentials. Once that's complete, you can close the importer, and let's put this at the top of the screen. We'll go ahead and anchor it to the top middle like this. And then we'll give an offset of about -30. And we will rename this to time interval text. In our script, we're going to need a hook to this so we can communicate with it. So open our script back up, add the library tmpro, add a variable of type textmeshpro GUI, and we'll call this time interval text. Go ahead and serialize this field so that we can get a hook to it in our inspector here. So here's our baseball spawner, and we need the time interval text in here, so you can select this and connect it as such. We'll make a string variable called waitTimeString, and we'll initialize this to simply have the string waitTime in it. And I'll put a line break at the end. And what we're going to do is continue to append times onto this. So in our function, we'll let waitTimeString equal whatever waitTimeString was before. Waittime is right here. Now we do need to convert that to a string so it can append properly. And then we'll add a line break at the end. Now we want to show that on the time interval, and we'll set the text equal to waitTimeString and show it in the user interface. And what we need to do is make sure that this is inside the infinite loop here. So we hop back over here, run it. We see the first wait time is 5 seconds. So after it starts, 5 seconds later, a ball appears. And the next one is going to be at 5 seconds. So these are consistent intervals that don't change at all. Every 5 seconds, a ball appears. We discussed earlier why it's not a good idea to have a fixed interval all the time. It can end up being too predictable and not fun for a game. Let's introduce the topic of probability density functions. And this is the likelihood of a random number having a particular value. Earlier, we looked at the concept of spawning an object every 5 seconds. However, we might want to spawn something on average of every 5 seconds, but not exactly every 5 seconds between each object. There are lots of different ways to come up with a group of numbers that average out to the value of 5. For example, we can set a range, say between 3 and 7, and choose numbers in that range where each number has the same likelihood of being used. This is the first probability density function, and it is called a uniform distribution. Looking at this graph, we have the numbers listed along the bottom on the x-axis, and going on the y-axis, we have the probability or likelihood that each of those numbers will be used. And we can see from the graph that the numbers between 3 and 7 have an equal likelihood of being used. So if we wanted to generate numbers with this probability, each number between 3 and 7 would have an equal likelihood of being generated. Next, we'll take a look at generating a list of numbers where the numbers generated are very close to the average of 5. This is called a normal distribution, or sometimes a Gaussian distribution or bell curve. And this simply means that most of the numbers that will be chosen will be around the average of 5. The next type of probability density function is going to be an exponential distribution. Here we have a list of numbers where the average is around 5. Take note that most of the numbers generated are less than 5. We can see from the graph that smaller numbers are more likely to be generated than larger numbers. Although it's not highly likely that a large number gets generated, but if a large number does get generated, we need lots of small numbers to offset that. Let's code some of these different distributions that we just learned about. First one we'll do is the uniform distribution. Head back over to your script for the baseball spawner. We're going to make a function very similar to the spawn baseball at rate, but this time we're going to call it spawn baseballs with a uniform distribution. With this one, we have very similar code. We're going to have an infinite loop. We're going to make a call to random number generator. I'm going to use the Unity engine one. And I'm going to specifically spell out the namespace because there is a random inside of system as well, as shown here. We pass in the range, and it returns us back a number between min and max, and we will call that wait time just like we did above. The rest of the code is copy and paste like the one above. And instead of starting the fixed rate of 5, we'll take one with a uniform distribution. So we'll pass in values from 3 to 7. We will never get a time less than 3. We will never get a time greater than 7. We start it and we'll take a look at our list of times. And our first one is 6 seconds. Our next one is about 4. Now we're close to 7. And with the magic of editing, you can see our list of wait times ranges between 3 and 7 seconds. Next, we'll do the Gaussian distribution. To do that, we need a helper function. As shown here, we make a function called Gaussian random. We're going to pass in the mean and the standard deviation. The standard deviation is essentially the width of that bell curve. So a very small standard deviation will keep the numbers very close to the mean, and a wide standard deviation will let the numbers have more variance and they'll be farther from the mean. To implement that, we choose 2 random values, value 1 and 2, and we just make a call to the math square root function. Multiply it by the natural log of the first number times the sine of 2 pi times the second random number. And then we return the average plus the standard deviation times this random standard normal that we just found. So to implement the Gaussian, we can copy and paste most of what is up here at the uniform distribution with a couple minor changes. We still have our while loop here that's an infinite loop. And what we do, we call our Gaussian random helper function that we just created, passing in the mean and standard deviation. And we have a little bit of safety code here. What this does is it deals with the possibility that the wait time is less than 0. And it just caps it off to a floor of 0. And then everything else is the same as the function above. So we have this set to be uniform currently. So we will add a function and we will spawn baseballs using our Gaussian. And we want to pass in an average of 5. And we want a standard deviation. And with a standard deviation of 0.5, that means that 68% of the balls generated will be in the range of plus or minus 0.5. So that would give us 4.5 to 5.5. So 68% of them will be within that range. And 95% of the balls generated will be within 2 standard deviations away, which is 4 to 6. If we make the standard deviation larger, then we will have more variance in our values generated. And the first ball came out at 5.04. Next is 3.81. And once again, with the magic of video editing, we can see our list here. And we can see that most are right around 5. And the baseballs appear to be practically the same distance apart. Let's change the standard deviation to 3.0. And what that means is with a standard deviation of 3.0, it means that 68% of the values generated will be between 2.0 to 8.0, and 95% of them will be between negative 1.0 and 11.0. Now we know that this will be capped off to be 0 in our code. And here we see we have a 2.3 and a 10.8, so much more variance in this version. And we're still going to get an average of 5. And when we speed ahead, we see there's a clear observable difference. Our wait times vary quite a bit, and I'll put this back to 0.5. And then we'll move on to the last one, which is an exponential distribution. To do the exponential distribution, we have to write another helper function to generate an exponential random number. So we'll go down here. We will write the function called exponential random, and we pass in the mean. That's the average. And once again, we invoke a random value, and we invert it and multiply it by the natural log of 1 minus the random number. We write a similar function. This one will be spawn baseball, exponential distribution. We will pass in the mean. So we will copy and paste. This time we call exponential random, and we only have a mean variable. We don't need this check here for a value less than 0. It's not possible. And the rest of the function is the same. Head back up to the start, call start coroutine. This time we're gonna do call baseballs at exponential distribution. We will pass in a mean of 5. And of course, don't forget to put a while loop around your code here so that it continues to spawn indefinitely. And our first one was at 9.36. Our next one's at 1.69. So we're going to need several small ones to kind of offset that bigger one. And we can observe that most of the values produced are small and there are less larger numbers. And that is consistent with how the exponential distribution looks. And once again, we fast forward, we see that most of the numbers are small with a few occasional large numbers. And that's how you create an object spawner with various probabilities. I hope you learned something today. If you did, buy somebody a brownie. Have a good day.